Hi everyone. I'm Yash. I'm a ECBA certified business analyst. Welcome to my customer churn analysis and customer intelligence portfolio project. In this project, I'll use SQL and Python to analyze customer churn for an OTT streaming platform. So the goal is not simply to write code or create charts. The objective is to understand which customers are leaving, why they are leaving, and what the business can do to improve customer retention. Moving on to the next slide. So, why churn matters? Before starting the technical analysis, it is important to understand why customer churn matters. Now, in a competitive OTT market involving companies like Netflix, Prime Video, Hotstar, retaining existing subscribers is extremely important. So, when a customer cancels, the business does not only lose 1 month of subscription revenue, it may also lose the customer's future revenue, potential plan upgrades, add on purchases, and long term relationship with the platform. The churn can also strengthen competitors because customers may move to another streaming platform. Therefore, the main business question is who is churning and why are they leaving? Now, the objectives of this analysis. This project uses SQL and Python to conduct a structured analysis of customer churn behavior. First, I will identify customers who have cancelled their subscriptions. Next, I will analyze churn patterns across customer demographics, subscription plans, contract types, tenure, and other behavioral factors. I will also study customer support behavior, including complaints, escalations, and customer satisfaction scores. So the project will then measure the financial impact of churn and conclude with data backend recommendations to improve customer retention. The scope of this project focuses on who churned and what they churned and why they churned. Predicting exactly when a customer will churn normally requires machine learning. So that falls outside the current project scope. So that's why we normally focus on who churned and why they churned instead of focusing on when. Because when is normally which requires like machine learning, future predictability. So we are not focusing on that. We are just focusing on who and why. Okay. Moving on to the next slide. So data for this project is stored in SQLite database file called customerchurn.db. So SQLite is a lightweight relational database system. Unlike larger database systems, it does not require a separate database server. Everything is stored inside one portal.db file. So this database contains three relatable tables. First is the customer table, second is the subscription table, and third is the support table. So all three tables share a common field called customer ID, which allows the record to be connected during analysis. Then there are the three perspectives of the customer. Now each database table represents a different part of customer relationship. So the customer table gives us the customer profile, including information such as location, gender, date of birth, interest, and PIN code. The subscription table represents the commercial journey, including plan type, contract type, subscription dates, monthly charges, cancellation information, customer lifetime value, and churn score. And the support table represents the customer experience, including complaints, escalations, satisfaction scores, and support comments. So individually, each table provides only one part of the story. Together, they create a more complete 360-degree view of customer and support deeper churn analysis. Moving on to the next slide. So tech stack used in this project are, so the project uses a focused Python analytics technology stack. SQLite and SQL will be used to connect to the database and retrieve relational data. Pandas will be used to import, organize, clean, and analyze tabular data. NumPy will support numerical calculations and feature engineering. Matplotlib and Seaborn will be used to create visualizations that communicate churn patterns clearly. And JupyterLab will serve as a main working environment, bringing code, SQL queries, charts, outputs, and written explanation together in one notebook. Now, the first technical milestone would be connecting the SQLite database to Python. Now, before any analysis can begin, Python must be given access to the database file. So in this section, I'll connect Python to customer churn.db, identify the tables stored inside the database, import those tables into Panda data frames, and inspect their structure. This creates the data foundation required for cleaning, feature engineering, exploratory analysis, and visualization. So this section follows a structured workflow. First, I'll import the required Python libraries. Second, I will create a connection to the SQLite database. This is a step-by-step workflow. And so first I'll import the required Python libraries. Second, I'll create a connection to the SQLite database. Third, I will query the database metadata to identify the available table names. Fourth, I will import each SQL table into Pandas. Fifth, I will inspect the database schema, including the column names and data types. Finally, I'll close the connection after the required data has been retrieved. So from raw database to analysis-ready data. So this step creates a bridge between the database and Python analytics environment. Python first opens a connection to SQLite. It then sends SQL queries requesting the required information. SQLite returns the results. Pandas convert those results into data frames, which are table-like structures that Python can clean, transform, and analyze. So every later insight, chart, and recommendation depends on this initial connection being completely correct. Moving on to the next slide. This is the last slide. So this is a transition to Jupyter Notebook. So we now understand the business problem, the project objective, the database structure, the technology stack, and the workflow. Now the next step is to move into Jupyter Lab and begin the the practical implementation. So I'll start by opening the project notebook, importing the required libraries, connecting to the SQLite database, retrieving the table names, and loading the database tables into Pandas. So yeah, let's begin with the hands-on analysis. I'll continue that in the next video.